Okay, so this is the assignment you're going to have today. The first ones in the assignment, I hope, will go quickly. You're just going to say if it's arithmetic or geometric, or if they're not arithmetic or geometric and what. So anyways, I need to teach you what all that stuff is, but that's what you're going to be doing. So it's not like you're doing tons of calculations. It's just do this, do this. And at the end, I'll answer some of the questions from last time's assignment. So anyways, so that's the assignment. There are a lot of problems, but at the same time, they're quick, I hope. Okay. This, uh, these two story problems, something very similar has been on the final the last few years. So those are good problems to really look at and understand how they work. Okay. So, anyways, I don't know if they're exact, but from what other students have told me, they're like, these are similar to what we've seen. So the first thing we need to do is figure out what arithmetic and geometric are, right? So you've seen them, you just didn't know what they were called. So arithmetic sounds like add, right? Arithmetic and such. So arithmetic, you add or subtract by the same amount each time. So like 1, 5, 9, 13, 17, dot, dot, dot. So that's arithmetic because you're adding by 4. And they call that the amount that you add or subtract each time, they call that the difference. They label it as D. So they'll say find the common difference if it's arithmetic. So the common difference would be D is 4. I guess we might as well use that example and carry on with it. We'll make a formula out of it, or make a general equation for this. So if it's arithmetic, it will always follow this pattern. AN equals DN plus C, which D is the difference, N is the term you're after, and then C is A1 minus D. Or if you want to think of it this way, it's the 0th term. So it's the term before the first term. So that's what C is. Term before the first term. So if I had you writing an equation for this, what would be the term before the first term? Yeah, because you'd go 1 minus 4. You can go backwards. Instead of adding 4 to find the first term, you're going to subtract 4. So if you put it in here, it'd be 1 minus 4, which would be negative 3. So that would be C. So your equation for this, the general equation would be AN equals the difference, which is 4, and then the N, and then the C, which we just said was negative 3. So that's the general equation of an arithmetic sequence. Uh-huh. So once you calculate that C term, then you can figure it out from there. So I'm trying to think of another problem, but I'll look for one. So that's arithmetic. Geometric is like this. 64 16, 4, 1. What's happening each time? Yeah, we're dividing by 4. So geometric, you multiply, and dividing is really just multiplying by a fraction. So like dividing by 4 is multiplying by 1/4 each time. So multiply or divide by the same amount each time. And they call that the R, the ratio. So when they ask you to find the common ratio, that's what you're multiplying or dividing by each time. So what's the common ratio? The common ratio would be 1/4. So that's what you're multiplying by each time. Geometric, it's easier to find the formula for it if you know the first term and the R. It's pretty straightforward. AN equals A1 times R to the N minus 1. And it's N minus 1 because the first term you haven't multiplied by that 1/4 yet. So this R in the first term hasn't taken place. So when you put the 1 in there for the first term, 1 minus 1 is 0, meaning I haven't multiplied it by any R's yet. The second term, you've multiplied it by 1R. The third term, you've multiplied it by 2R's. So it's always, there's 2 R's, or not 2, there's always 1 less R than the term you're after. So like, see, here's the first term, no R's. There's 1R, there's my second R, there's my third R. So for the fourth term, there were 3 R's. So 1/4 to the third. And we started with the first term, and we multiplied 1/4 in there 3 times. So anyways, this formula for this equation would therefore be the first term, which is 64. R is 1/4. Then N minus 1. So that's the general equation for that will generate this sequence of numbers. Okay, so there's 2 different problems. I want you to come up with a general formula for each of those, and I want you to come up with the first term for each of those. So on the first one, it's arithmetic. So I'll tell you that much. How would I come up with the general? First of all, what's the difference on this problem? If I go from 21, so here's the way you can do it. Take the upper one minus the lower one. So the bigger one's 9 minus 21. And how many terms does that change over? Yeah, so that's 12. And it changes, it went from A7 to A3, so that was a difference of 4 terms, right? So how much did it change each time? So it went down 3 each time. Okay. So it went down down 3 each time, which means that A2 is what? 24, A1. And if we had to go back one more, it would be 30, which that's really just C, right? So my formula is going to be AN equals the difference, which was -3, and then the N, and C was A1 minus D, which we already determined was 30, plus 30. Now on this one over here, how many times do I have to multiply? If I'm at R5, how many times do I have to multiply by R to get to R8? One R would make R6. R7 would be another one. So R8 is, so I multiplied it 3 times, right? So R cubed any ideas how we're going to do this? We're going to divide those. So I multiplied something 3 times to get, I think that's right. So what's 256 divided by 32? So R cubed equals 8. So what does R equal? Take the cube root, and you get that R equals 2. Okay. So now I can just go backwards. R4 would be R cubed, 8. R2, and R1 is 2. So my general equation for this would be A1 or not A1, AN equals A1 times R to the n minus 1. So A1 is 2, and the R is also 2. I should have used a different number. So anyways, that's how you come up with the general equation for those problems. Let's suppose you start with 1 and you count by 1 each time. Is it arithmetic? You're adding by the same amount each time, right? So let's say you'll go all the way up to 100. I need some more. Hold on. 96, 97, 98, 99, 100. Let's start with something else now. Let's start smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. I want you to add all those numbers together. What's 1 plus 9? What's 2 plus 8? What's 3 plus 7? What's 4 plus 6? And then you're left over with 5, so it's 45, right? By the same idea, if I go 1 plus 100, what is it? 2 plus 99. 3 plus 98. 4 plus 97. 5 plus 96. What do you think they're all going to be? Okay. Now this one, how many numbers were there? How many tens were there? 4.5, right? 5 was half of that. So if I have 100 numbers, I would have, so if I have 100 numbers, there would be how many pairs of 101? There'd be 50 pairs of 101. Okay, so here's the quick way if it's an arithmetic sequence. It's going to be the number of terms that you have divided by 2. Why 2? Yeah, how many pairs? And then it's just going to be the first term plus the last term. So first term plus the last term. This is what got one of the famous mathematicians kicked out of school. His teacher told him to go outside and count up all the numbers from 1 to 100. He came back in like in a minute or two. It was like, there's the answer. They're like, you cheated. You did something, and kicked him out. It was supposed to take him longer than a minute. He's like, saw the pattern. The teacher wanted me to be like, 1 plus 2 is 3, 3 plus 3 is 6. Anyways, so that's the sum of an arithmetic sequence, okay? So once you, here's how it's written in the book. So they'll have something like that. That says an 18 on the top, and that says a J right here. So J plus 6. So how many terms are there if I start at 1 and go to 18? 18. So I'd put that in my formula, 8 divided by 2. My first term is when I plug 1 in for J, because you start with the bottom one down here. So I plug 1 in for J. 1 plus 6 is 7. Then my last term, I plug 18 in there for J. So 18 plus 6 is 24. So I have 9 times 31, and that would be my answer. So when it's set up like this, you just plug in the first number on the bottom, that gives you your first term. Plug in the number on the top, that'll give you your last term. And then the number of terms is from 1 to 18, so that means there's 18 of them. Finite means what? It ends. Infinite means it never ends. Now, how are you going to add a series of numbers if they never end? So you can't, but you can come really close if what? Any ideas? Here's you a thought. Suppose I start with 10 and I take half of it each time. What's half of 10? And then 2.5, and then 1.25, and then whatever half of that is, 0.625, and so forth. It keeps getting smaller and smaller, right? Eventually, I'm going to be adding somewhere out in here a very small number. Is it going to make much difference? And eventually that number gets so small it's like I'm really adding 0. Even though it's infinitely, this series goes on forever and ever and ever, because we're adding such a small number, it's like it ends. So the only way you can add an infinite one is if the ratio, the absolute value of r, is less than 1. Okay, if it's bigger than 1, as you said, it never stops, and so you cannot add them all together. And it's the easier of the two formulas. The S means the sum. It's just A1 over 1 minus R. So the first term over 1 minus R. So if I were to add up all these numbers, the R in this problem is 1/2. The first term is 10. So 1 minus 1/2. What's 1 minus 1/2? Still 1/2. Well, 1 minus 1/2 is a half. And how many halves can you make out of 10? Right? If I have your dollar, then you change into 50-cent pieces. Each dollar is two 50-cent pieces. Or when you divide by a fraction, you reciprocate and multiply. So if I were to add these all together, I would get up to 20. Really, you never would. You'd be out here like this. But it'd be so close to 20 that you wouldn't know any different, because this would keep going out there forever. So that's the easy one of the two. Okay. It looks like this when you're writing them down. I equals I'm trying to remember if it's 0 or 1. That's a trick question they'll throw at you. It needs to start at 1. If it doesn't start at 1, it changes things up a little bit. Okay. So that's how they'll set it up looking like that. And then they'll have something like this, 3/4 I minus 1. You just plug in this 1 to get your first term. Now for the more challenging formula. It's not that it's more challenging, it's just that it's not as easy to remember. I always put this n on the wrong place. I put it on the outside. And these numbers get big fast. So there's an example problem. So the formula, if it's a finite one for a geometric sequence. So again, we need to find the first term. So I plug in the 1 down here. So 1 minus 1 is 0. So anything with 0 power is 1. So 4 times 1 is 4. So A1 equals 4. Because I plugged that 1 in here. So 1 minus 1 made the 0. To the 0 power, anything with 0 power is 1. So now, plug it into this formula. A1 is 4. 1 minus r. R is the number that's got the parentheses around it, that has the power. So r is 1/2. And this 1/2 is going to be to the n power. So how many terms are there from 1 to 6? 6. If this would have started at 0, how many terms are there from 0 to 6? 7. Because you're starting at 0 instead of at 1. So it adds 1 more on. So be careful about that. That's the trick they'll throw at you. Now it's all over 1 minus r, which is 1 minus 1/2. So if I were you, I would actually just do this in my calculator. So when you do it in your calculator, make sure you put your parentheses on there. So I'm going to go 4 parenthesis 1 minus parenthesis 1 divided by 2, close that parenthesis to the 6th power, and then close that parenthesis. And then I'm going to hit enter. And then I divide that by 1 minus 1/2. So it tells me that it's 7.875. You could actually probably do this another way. I mean, you could take it and say that first term is 4, and then we're going by each one, multiplying each one by a half. So 4, 2, 1, 1/2, 1/4, 1/8, 1, 2, 3, 4, 5, 6, 1/16. Then add those all together. 1, 2, 3, 4, 5, 6. Whoops. The first 6 terms. And now just add those all together. And that would give you the same answer as this. So that is another way to do it. But anyways, that's today's stuff.